situation that may occur in the future. Playing it, the nature. Static nature, the actual event. Whether it is actual events, what may occur in the future. So, for example, the state number, the state events, the economic conditions, bad economic conditions. There are chances to happening both. Sometimes they are maybe good, sometimes bad, or right? It's physical. So that's why I say the state event is an actual event. That may, so it's not 100% sure, that may occur in the future. That may occur in the future. So this is one of the terminologies to understand. And basically, there are two categories of decision situations. Basically, there are two categories of decision situations. That are probabilities are assigned. Knowing the probability, not knowing the probability. Regarding some future events, we know the probabilities.
Recording in progress.
Not knowing the probability. Knowing the probability and not knowing the probability. So these are the two categories of decisions. So that to complete this section, these basic knowledge are needed. Terminology. What are the two categories of decision situations? One is probabilities. That means chances for happening that can be assigned to the future happening. Second one is that probability means we don't know the probability. Right? We don't know the probabilities. Okay? We don't know what these are the two things. And also that payoff tables. The payoff table is means or that indicate the organization of decision situations is an organization of setting up a decision situation, including the payoff from different decisions given at various state of natures. So the decision situation may be, say for example here, decision situation may be 1 to 3, purchasing apartment buildings, purchasing apartment building, office building, or purchasing warehouse. These are the 3 different decision situations. Right? The state of nature is good economic conditions and poor economic conditions. Right? So by incorporating the decision situations, decisions type of decisions, and state of nature, we can able to pay off them. How much is return or income or loss we get it. So the payoff table is the actually it should have a state of nature and also that decision situations, so that type of decisions, right? How much financially we gain or lose. Financially, how much dollars or how much money we will gain or lose, that information also there. By incorporating these 3, we can develop a payoff table. So to understand this, these 3 things are basic, right? Type of decisions, state of the nature, and what is the payoff tables. So the very simplified, summarized definitions are given at the left-hand side of this material, right? The 2 categories of decisions, what are those? One is probability knowing, other one is not probability knowing. Right? Second one, in the state of nature means what? It's an actual event that may occur in the future. Third one, what is the payoff table? Actually, payoff table is the organizing decision situation, including payoff. Payoff means returns, right? It may loss or profit, or income or loss, right? From different decisions given at various state of this. So it's a coordinating. You see, apartment building. If it is a good economic condition, how much we can get it. For the same decisions, if it is a bad economic conditions, how much our return. So if you are going for office building, how much we can get it. If it is a good economic condition, and poor economic or bad economic conditions, we have to pay 40,000. Loss may be given in a bracket or a minus value. PKR. And if it is given in a bracket, means that is a minus 1. And warehouse, if you purchase in warehouse, if the economic condition is very good, how much we can get it, and state of the area, how much we can um, use it. So, to economic condition. Please mute that so that um, please mute. Right? So that then now it's how we are going to make a decision, right? How we are going to make a decision, right? How we are going to make a decisions. Once join with your names with numbers. Then now is how we are going to make a decisions. There are certain criteria applicable. Means the way we are making decisions termed as max. First one is a maximax. So what is maximax means? Making a decision considering maximum of the maximum pair. Maximum of the maximum pair. Now you see the state of the nature is here only two, maybe three also. Average economic condition, good and poor. Right? So in this example, for understanding purpose, they have only given only two. Right? So that maximax criteria, right? According to the maximax criteria, simply you have to look into the apartment. If you purchase apartment building, what is the maximum for the 50,000? That is maximum. Because for these decisions, comparing to decide the maximum. The second one, office building, if you go for office building division, maximum is 1 lakh. House maximum is 30,000, comparing with 10,000. Comparing with 10,000. Then we have to take out of all maximum values, which is the highest. That is about 100,000. That is about 100,000. So going for office building, according to the maximum payoff, according to the max criteria, we have to go for office building, right? That is a one. Then maxi mini means let's make the mini. The maxi mini means maxi mini criteria says the results in the maximum of the minimum period. So first decision, what is the minimum? 30,000. Second one, minimum is loss, 40,000. Third decision, warehouse, minimum is 10. Out of all this minimum value, what is maximum? 30,000. So therefore, that is the decisions according to the maxi mini criteria. So 30,000 is the uh, maximum payoff according to this maxi mini criteria. So be careful, it's a maxi mini, right? Okay. The third one is about mini max regret criterions. Here they use regret criterions. Regret is the difference between the payoff from the best decision and all other decision payoff in a particular state of the events, right? So according to this one, we have to first develop the regret table, and you see that uh, the first conditions, good economic conditions, maximum value is 1 lakh. 1 lakhs minus 50,000. So then 50,000. The second one, 1 lakh minus 1 lakh, 0. Then 1 lakh minus 30,000 is a 70,000. So this is about these calculations needed to prepare a record tables. Similarly, for these poor economic conditions, the maximum is 30,000. So 30,000 minus 30,000. Then the second decisions, 30,000 minus 40, that is 70,000. And third one is 30,000 minus 10,000, that is 20. So minimax record criterions, according to you, first we have developed these regular tables. Now you see as a summary of this calculation, 50,000, 0, 70, 0, 70, 20. We have developed the regular table. So this is called a regular table. How to get regular table? Right? For each separate state of the events, consider maximum and minus is the value. So in these conditions, you see this is the sum, original sum. So this is the maximum one. Good economic conditions. Poor economic condition, this is the maximum. So minus it all the things. Right? Then we can get a record tables. Actually, this record table is the difference between the payoff and the best decisions with a particular state of the nature and all other decision payoff. That's it. So after that, we have developed the record tables. The record tables, you see that the criteria is minimax. So here the minimum is 70 and 50. So three values are 0, 70 and 50. So according to this table, minimum is 50, not 0. 0 is nothing. 0 is nothing. Right? 70, when comparing 70 and 50, 50. Then likewise, poor economic conditions, comparing 20 and yes, poor economic conditions. Yes, poor economic condition is 20. Right? So now we look into that based on this table, minimax. Minimum. Yes. Minimum. So according to that, after developing a record table, so this level is so then how we are making a decisions according to the mini max record. According to the mini max record, the maximum record from the each decision must be determined. This is the steps I am missing. The maximum regret from each decisions must be determined. So here 70, for economic conditions, the maximum one is 70. Here also, particularly the max record criterion, the maximum record for each decision must be determined. The decision corresponding to the minimum of this record value then selected. Okay, maximum has to be determined, minimum has to be selected. That is the decision. Okay, right? So it's okay. So according to this table 12.6 is given, maximum has to determine, the selection is the minimum. So therefore, here the maximum minimum. So according to the max record criteria, this should be the apartment building rather than office building. With building a warehouse, the particular decision is based on the philosophy that investors will experience least amount of regret purchasing the apartment building. In other words, the investors purchase a office building or warehouse 70 word regret results, however, purchasing this building for 50,000 regrets. Right. There are some conclusions. So, you know, so, max. Okay. Right. So, right. This is in the first economic conditions, minimum is 50,000. Poor economic conditions, minimum is 20,000. Like that is the range. Right. Carefully think that according to the record table, um, good economic conditions, minimum is 50,000. Right. And poor economic conditions, minimum is 20,000. You don't need to consider zero because zero is nothing. So out of these two minimum values to the right. So we have to consider about maximum. That's why it's a 50,000 is selected. Right. Be careful this. After preparing record table, we have to consider in both there are three situations, state of the natures. We have to consider the minimum. So you see 70, 0, 50, 0, 70. Out of this minimum is 50. Okay. Under the good economic condition. Similarly, under the poor economic conditions, the minimum is 20. Right. So in between 20 and 50. Right. In between 20 and 50. Right, in between 20 and 50, we have to consider max. So 50 is a max. That's why mini max record value. So mini max record value here is 50 because you see mini. So that according to the good economic conditions, state of teenagers minimum is 50,000. According to the poor economic conditions, minimum is 20. That is about this mini indicate. Out of these two minis, we have to consider max. So as per the state of nature, 2 mini is 50, 1 mini is 50, 1 mini is 20. Out of these two mini, we have to consider max. That's why apartment building is going. Okay. So, okay, that's okay, right? So, I forgot to explain a moment. That's how the decision we have to make. So, especially for the max, mini max record criterion, we have to develop the record table. From after developing a record table, just take the maximum one minus it, each value for the each economic conditions, separate good and bad, good and poor economic conditions. Then we have to look into that, the lowest one, the minimum one on each conditions. Right? Minimum one on each conditions. So that good economic condition, minimum one is 50. Poor economic condition, minimum one is 20. So out of this 50 and 20, maximum is 50. Going for apartment building or purchasing of apartment building has to be a decision. Has to be a decision. Okay? That's how it's. Recursive criterions. This is about actually here they are using called coefficient of optimism. Okay. So the coefficient of optimism actually right? Don't misunderstand, because all these things are non-probability decision making. Probabilities are not known. Probabilities are not tested. So therefore, here coefficient of optimism. Coefficient of optimism is given. That is called alpha value. This alpha value, based on the alpha value, we can make additions. The rest of the part 1 minus alpha, right? So here weightage, according to first division criteria, it's actually the between maximax and minimax. In between maximax and minimax, this decision is fall into that, right? So that's why it's a compromise between maximax and minimax. That's why this weightage is given. Okay, but don't misunderstand. It is not a probability. Okay, so weightage is given. The weightage is considered as a coefficient of optimism. It's alpha value. So that's here you see in the right hand side. We mentioned about coefficient of optimism is alpha. It's a measure of decision makers' optimism. Optimistics means very positively they look into it. So in this example, they have given alpha value is 0.4. 0.4. So optimism. So that means the state of nature, they are giving a weightage 0.4 all type of decision because good economic conditions. So the weight for a bad economic condition is 0.6 because 1 minus alpha is that balance. That is for pessimistics, right? So the weightage for not probability, yeah, weightage for optimistics approach is 0.2. That is alpha, right? And if it is weightage is given for the positive things, the rest of the things is the negative aspects. Pessimistics is a 1 minus alpha. So that's why it's getting 0.6. Sometimes if the optimistic say is a 0.6, the balance should be optimistic or pessimistic one. So vice versa, that things may happen. So in a good economic condition, all the things has to multiply by weightage, alpha value, 0.4, 0.4, 0.4. Similarly, the poor economic or bad economic condition has to be multiplied by 1 minus alpha value, the balance value, 0.6, 0.6, 0.6. After multiplying this way off, we have to careful the minus value also. Then we have to add both. So if you add the 50,000 has to multiply by 0. Plus 30,000 has to multiply by 0.6 equal is a $38,000. That is for apartment buildings, right? Similarly, for the office building, right? Office building 1 lakh has to be multiplied by 0.4. The balance has to be multiplied by minus 40. Net effective 16%. For the warehouse, 30,000 has to multiply by 0. Plus 10,000 has to multiply by 0.6. Then the absorption is 18,000. Okay. So according to this, after doing this, we have to consider the highest one. Weighted value for 38,000 of this example. This addition would be obviously. This is very easiest one. You have to carefully look into that. Coefficient of optimism be given. So that only coefficient of optimism is given, not pessimism. Then rest of the things assigned to pessimistics, negative aspects. So the balance has taken. So that is easiest. Then equally likelihood, equally, then other one is equally likelihood. Here, the weightage is given 50-50 times. Here also they say it's not the probability, it's a weightage. They are giving equal weight, 50-50. So for good economic conditions to happen, 50 chances, weightage, not chances, weightage. And that also, for also 50 weightage. So then we have to multiply, then we have to consider about highest. Multiply and edit. there are minus payoff, you have to be very careful. So here also, according to equal likelihood, also 40,000 become in addition. Okay. So then the summary, all these mini maximax, minimax, minimax vector will give now Novix and equal likelihood. Novix and equal likelihood. The final decision is except the first one, the things are apartment building. It's the more profitable, more feasible. So that's the point. So all these things has happened based on non-probability basis, right? Non-probability basis. So because initially we have, like I said, that two ways we can get into this. Probability can be assigned, two type of decision situation, and this probability can be assigned. So far what we have learned all these techniques, 10 techniques. Yes, these three, um, 4, 5 techniques in the non-probability. Okay. Then next section is about making decision with probabilities. Each and every values, the occurrence, we have judged with the chance of occurrence, possibility to occurrence, possibility to occurrence. So therefore, by multiplying the probability values, we can generate the expected value. Here they use a technical term called expected value. The expected value is computed by multiplying each decision outcome payoff under the state of nature by probabilities which difference or probability will be given. So for the given probabilities, we have to do the calculations. Expected values are given based on expected value is computed by the probability of each decision's outcomes in the each state of the nature by the probability of it. That means probabilities are given. Okay, probabilities are given. So just the expected value is calculations, that's multiplied by this. So the same examples, three decision situations, two state images, we can calculate the expected value. The probabilities are given. You see in this example, the real estate investment, suppose that several economic forecasts, the investor is able to estimate 60% probability for good economic conditions and 40% probability um, poor economic conditions. So the 60% is therefore good economic conditions. So all the values has to multiply by all the values which are coming on the economic condition has to be multiplied by 0.6. Then poor economic conditions, again, all the value has to multiply with 0. Always probability of weightage to be 1, equal to 1. Okay? So then 30 minus 40, 10, then we can get it 42,000, 44,000, and 22,000. 22. The best decisions, this is according to me, 44,000 would be the results. These decisions for in one of the greatest expected is 44,000. Even though there is a poor economic conditions, it's 44,000 is the best decision to take the does not mean 44,000 will result the investors will just this building. We assume that one of the payoff values comes the value that the situation large average payoff. Actually, it's an average. Something's going to happen, we don't know. We predict the chance. And averagely, payoff is we make that time. Therefore, we are going to. Yeah, accordingly, alternate the payoff first terms cost and the best decision would be one the lowest expected value. All right. So now you see that critically look into that. Yeah, loss is also there, but this is losses offset by the good economic conditions. It is the realities. Otherwise, if you say sometimes while we are choosing this purchase, there are poor economic conditions, there will be yields. We basic for the loss. Okay. Then expected opportunity loss. It's a loss expected value of vendor from the each decisions. Here they are considering about the opportunities, opportunity cost is given. While taking something, the thing has ignored. While choosing for the best one, the thing has ignored. Those two options, binary format is. So therefore, while we are losing one thing, the decision-making point, there is opportunity. That's why it's here opportunity lost probability is big. So here you see that the opportunity lost. So same as regular table. That's the same as table. Yes, no? Maximum one is 0.70. Is 0.70. Is 0.70 and 0.70 20. For maximum one, we have to make it. So that is opportunity loss. Then we have to assign the probability value. Here, the first one, 50,000 to 0.6. You see that one important additional information is given. Right? Earlier one is not there. Right? If you carefully observe the lesson material or the chapter, you can understand it. There is no probability based decision making, that value is not there. Only the probability based decision making, this value is right. Okay, therefore here we have to multiply after getting the opportunity loss table. For the respective probability, we have to multiply. Even if it's zero, that assignments. So 50,000 first table, 50,000 multiplied by 0.6, here 0. Second, 0 multiplied by 0.6, here 70 multiplied by 0. And third one, warehouse decisions, warehouse purchasing decision, 70,000 has to multiply by 0.6, and poor economic conditions, 20,000 has to multiply by 0. So after taking this value, multiply and add it, so 30,000, 28,000, 50,000. So according to this, we have to go for the recent situations. It's 20, because 28,000 is the minimum expected rate. So addition is now after doing this, we have to choose the minimum one. Because it's a loss. Because it's a loss. This opportunity loss. Less opportunity loss is the decisions. Be careful. Don't go for the maximum. Here, expected opportunity loss. Whenever the minimum loss has to be considered for the decision making. So according to that, office building is the best. right? Because now is actually by assigning these probability values, we are making these calculations. Okay? So actually, it's given expected opportunity loss. Okay? The expected opportunity loss, we have to look into that low loss, lowest loss. That is advantage for us. Highest loss is disadvantage. Low loss, in terms of loss, we have to minimize. So the minimum one is 28,000. So therefore, this building is the efficiency. So now you see here, the one of the challenging is in this chapter is in this section is decision analysis. We have to carefully remember by using some shortcut the decision criteria. Otherwise, it will confuse you. Probability, non-probabilities, what are the things are coming under probability, other things are coming under non-probabilities, and how to make additions. Next, we have to develop a small short table, right, for your recalling purpose. Right? Otherwise, during the examination, you will suffer a lot because even though it's a very simple sections, if you take a wrong decisions, the decision criteria, if you forget, you cannot make the decisions, or you have to take a wrong decisions. So therefore, this is the risky section, but easy, but there is no risk. Yeah. And you have to very clear about the decision criteria. Okay. Good. So then, the one is the perfect information, expected value for perfect information. This is expected value for perfect information. EVP is the maximum amount a decision maker would pay for additional information. So if you know the perfect information regarding the future events, that is we are using the risk. So I say perfectly we know what happened. So probability is chances. Probability is here. The things they say about the table solution given for perfect information. This is 60,000. Here, apartment buildings, that is the here is lowest one. This is the best one is 30,000. Here, best one is a 1 lakh. Best one is a 1 lakh. So the probability is also given 60. So 1 lakh has to be multiplied by 0.6. Yes. This were economic condition 30,000 has to multiply by adding more, you can get 72,000. So this amount, 72,000 is expected value conditions given in the perfect conditions. So according to that, extra amount would be paid by gain informations that would be the decisions better than the other made. Okay. So the next solution has to be taken. For that, this is this building. This is for apartment buildings. Right here is a, you see it's a combined. So if it is for office one, with this last one and 40,000. Yes. It is after getting this value, 72 minus this gain, net gain, 72 minus this gain, it should be equal to, so 72,000 already we have calculated. We get it according to perfect information. Here the maximum one and here the maximum one, 72,000. We have to get it. Then after that, we have to calculate for the office building separately. you see the 100,000 and minus 40,000. 100,000 and minus 40,000 as per the probability. We have to get then from that 72,000 minus 44. That should be a 20. So the expected value of perfect information is 28,000. The maximum amount that investors would pay for purchase perfect information from the sources. How much we can pay for to get the perfect information or the accurate full information regarding, because information is the expensive one. Right? Information is the expensive one. Therefore, we have to look into that, how much we can pay for get information. Because information is not free. You have to pay. Right? So that's why it's kind of relations. And also the expected value of perfect information is equal to expected loss of opportunity in the best decisions. Also they have proved by opportunity loss. So this 28,000 equal to this 28,000, they have to show by expected opportunity loss payment. For this 28, you see that both value has same, right? So that that value has the what they have to pay for this X9 information, so the perfect information, and that this one this has to be expected opportunities. This to be it's only so please go through and practice and keep it on your memory regarding how to make additions. Knowing is okay. There's just only multiplications, selections. The addition criteria need to apply is the challenging one in these sections. Equal then the other option is the addition trees, right? Addition trees, you know that, right? There are same information we can put in addition trees. Say the purchasing, as you see, same information are given. Just three options, three branches. Whether we are going to go purchasing apartment building, office building, or warehouse. So poor economic conditions, good economic conditions. So by multiply this one, yes, 6, 30, so good economic conditions, 0.6. Poor economic conditions, the point altogether 1, so we can get it from 1. Similarly, for the office building, good economic condition multiplied by payoff as multiplied by 6, and poor economic condition loss 40,000 has to multiply by 0. Then we can see that possibilities. And also for the warehouse, right? So good economic condition multiplied by 0.6 and poor economic conditions by 0.6. You can see that possibility for taking decisions. Okay. So then, based on that, we can make a decisions after expected value computed as probability loss. We can see that which is the best option. Right here, in the good economic conditions happen, this is 50, 100, 30. Poor economic conditions 30, loss 10. Just only the sign. Probability will decide it. Then if you add it for the node 2, 3, and 4, we can get it this final decisions for that. Branches with the greatest expected value will be selected. Branches with the greatest addition on that branches means that net is decision tree diagrams, well, um, vision piece diagrams. 30, right? This 50, 30, right? 50, 30. Then 100 minus 40, that is the second one. 100,000 minus 40,000. Third note is about 30, 10. 30,000 and 10,000. Right, combined. Then adding that, then we can see again, which is the expected value is highest expected value is 44,000. So 44,000 is second node. Then solution is building. Okay, so that's how the decisions are making under these scenarios. Then we can put the values also. Okay, 44, 44, 22 in the decision tree diagram also, and we can calculate and make decisions. Okay, so this mm, so this is not needed for sequential decisions. Actually, it's a sequential decisions just as a situation requiring series of decisions. So let's continue, like many series of decisions while we are made. See that purchase apartment liquidation both no ways of it. So the purchase the land, liquidation both not building apartment, sell the land, develop a commercial, but is using the land. Like when there is a sequence of sequences given, right? So in these are sequential statistically going different branches has different situations. So then we have to do it by multiplying each branch divisions. Then we have to take the final decision needed. So we have to just combine it, and we can see ultimately what we can gain. That is so it's not for this. Okay. We have completed the syllabus, right? So I'm not. I have a class at right 12:30. They are in the medical faculty, so they have to leave it. And tomorrow in my class, and there's any other classes. Only my class is there for tomorrow. So the next week you have exams, network analysis. This other one is inventory control, right? So you have to be ready. That is the last two exams you have to face, right? Okay. So next week I will conduct your exams. Tomorrow I will have a MIS class also. Okay, thank you.
Thank you, sir.
Thank you, sir. Thank you.
Yes, sir. Thank you, sir.